करूं फिर से?
ओके ओके।
मैं कह रहा हूँ एक हमारी लैब है ना, जैसे
हाँ हाँ हाँ।
MGY-104 लैब।
यस।
अभी उसका प्रैक्टिकल इन्होंने शेड्यूल किया है हमारे रीजनल सेंटर ने 31 जुलाई को।
31। हाँ हाँ।
अभी उसमें हमें ये क्लियर नहीं है कि हमें ये अपनी प्रैक्टिकल फाइल भी सबमिट करनी है कि नहीं करनी है। अगर
प्रैक्टिकल जो
तो,
असाइनमेंट है ना।
नहीं असाइनमेंट, हाँ, जो हम जो रिटन पार्ट रहेगा
हाँ
वो सबमिट करना है वहां पे।
हाँ, अभी जो आपको एग्जाम है 31 को, तो आपको प्रैक्टिकल जो असाइनमेंट है जो दिया गया है प्रीवियसली, जो लेक्चर शायद हुआ होगा, मैं तो नहीं किया हूँ,
जी।
तो उसी का जो जितना दिया गया है उसको आपको प्रैक्टिकल एग्जाम से पहले सबमिट करना पड़ेगा, क्योंकि वो आपका मैंडेटरी है।
और इसका कोई है कि कितना वेटेज है प्रैक्टिकल फाइल का, कुछ ब्रेकअप वगैरह?
उसका शायद 10 या 20 है मार्क, टोटल मार्क। भाइवा में आपका 5 मार्क है। प्रैक्टिकल में आई
ओके।
थिंक 30 है, या इतना श्योर नहीं हूँ
हाँ,
मैं।
उन्होंने जो जो वहाँ पे परफॉर्म करना है वो 30 का है।
हाँ
अब इसमें एक चीज और है कि जैसे हमने एक सिस्टम पे काम करना है, तो क्या हमें अपना लैपटॉप कैरी करना है कि वो प्रोवाइड करेंगे?
नहीं, वो डिपेंड करता है। अगर आपका लैपटॉप में इंस्टॉल है तो आप अपने लैपटॉप में कर सकते हैं, ऐसा कुछ प्रॉब्लम नहीं है। अगर नहीं है तो वो जो सिस्टम देंगे तो उसमें से करना पड़ेगा। नहीं तो आप जो फाइल दिया दिया जाएगा तो उसको आप पेन ड्राइव में कॉपी करके आप लैपटॉप में कर सकते हैं, उसमें कुछ प्रॉब्लम नहीं है।
ये करना हमने QGIS
प्रॉब्लम
में ही
ये
है
है,
ना?
अभी अभी से बता देता हूँ। जो
जी।
भी आपके आपको एक राइटिंग के लिए एक दिया जाएगा, तो आपका
जी।
जो आंसर है उसमें जो प्रैक्टिकल का डिफरेंट प्रोसेस है आपको लिखना पड़ेगा, वो ज़्यादा इम्पोर्टेंट है। अगर प्रैक्टिकल में कुछ गलती हो गया भी तो
जी।
उसको मतलब मैनेज हो सकता है, लेकिन आपको जो स्टेप्स है, जो रिजल्ट है, उसको आपको राइटिंग में
वो
लिख के सबमिट करना पड़ेगा वो।
वो शीट पे सबमिट करना है ना हमने, शीट पे?
हाँ। यस।
उसके लिए अलग अलग से रिटर्न के लिए शीट रहेगा ना?
हाँ हाँ, रिटिन के लिए जो सीट रहेगा,
ओके।
तो उसमें आप जैसे भी हो आपको, क्योंकि वो जो राइटअप पे देख के ही मार्किंग देंगे। आपका फाइल अगर कुछ मतलब फाइल को इतना
जी जी
डिफेंड
जी जी।
करता है। तो
ठीक है सर। अभी
प्रैक्टिकल तो मैं
राइट नो।
प्रीवियसली, एक्चुअली प्रीवियसली मैं प्रैक्टिकल लेता था, तो अभी तो मैं नहीं ले रहा हूँ, नहीं तो मैं डिटेल्स में आपको समझा देता। अगर मैं अवेलेबल
आपके
होऊंगा
आपके
तो प्रॉब्लम कुछ नहीं। हाँ।
प्रैक्टिकल पार्ट का आपका आपने वीडियोस वगैरह बनाए हुए हैं, ये अपने वीडियो
नहीं नहीं,
रिकॉर्डिंग वगैरह कुछ?
प्रैक्टिकल का देखो, मैं अभी प्रैक्टिकल तो नहीं ले रहा हूँ। प्रीवियसली कोई और
जी
लेक्चर
जी।
ले रहे थे,
ओके।
तो जब बोलेंगे तो करना पड़ेगा।
तो ठीक है। तो राइट नो जो अभी हमारा यहाँ पे जो चल रहा है क्लास, ये कौन किस कोर्स का है अभी
कौन
जो
सा?
आप ले रहे हो? ये अभी
अभी
जो ये
अभी
थ्योरी का
देखिए, जो
थ्योरी।
राकेश का जो पार्ट था, उसका जो एप्लीकेशन ऑफ जियो इन्फॉर्मेटिक्स, तो
जी जी।
इसमें क्या है कि जियो इन्फॉर्मेटिक्स में बहुत से कोस्टल स्टडीज, कोस्टल सॉरी, बहुत से पार्ट है। तो इसमें से आज मैं कोस्टल स्टडीज का जो डिफरेंट एप्लीकेशन है उसका डिटेल्स में लेक्चर ले लूंगा।
जी जी। नहीं, मैं ये पूछ रहा हूँ कि ये हमारा कोर्स कोड कौन सा है
यस।
इसका, कोर्स का कोर्स कोड?
कोर्स कोड आप देखिए, आपका जो लिखा होगा ना।
शेड्यूल में?
हाँ हाँ, आज का डेट का जो है,
28 का राकेश रंजन सर, यू आर टेकिंग ऑन बिहाफ ऑफ हिम है?
ऑन बिहाफ ऑफ
उनकी तरफ से आप
राकेश।
ले रहे हो ना आज?
हाँ,
ठीक है सर, ठीक है।
ठीक
ओके
है।
सर।
आपका क्या है?
थैंक यू। आई एम डॉक्टर रोहित
हम्म।
फ्रॉम जम्मू।
अच्छा, जम्मू। अभी आप वहाँ पे जॉब कर रहे हैं क्या?
Currently I am working as assistant professor here in higher education department,
Which
J&K
department?
government में.
Higher education.
हायर एजुकेशन डिपार्टमेंट जहाँ पे डिग्री कॉलेज में पढ़ाता हूँ. यहाँ पे हमारे पास मास्टर्स है ज्योग्राफी का, तो
हम्म।
पीजी वाले बच्चों
हाँ,
को
मेरे
पढ़ाता हूँ.
साथ एक ज्योग्राफी के शायद असिस्टेंट प्रोफेसर एनआरएससी में एक ट्रेनिंग हुआ था, वहाँ पे गए थे हाइपरस्पेक्ट्रल
जी
रिमोट सेंसिंग में।
जी जी, कौन से, क्या नाम था उनका?
नाम तो पता नहीं, 2018 में शायद।
प्रोफेसर मोहम्मद सरफराज असगर तो नहीं
हाँ
थे?
हाँ 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 हाँ,
मैं उन्हीं
पतले
का
से थे।
स्टूडेंट रहा हूँ. जी जी.
अच्छा। हम्म।
सर ने मेरे को पढ़ाया है, उन्हीं का स्टूडेंट हूँ.
अच्छा अच्छा
पीएचडी सर के अंडर नहीं करा मैंने, बट मास्टर्स में सर ने पढ़ाया है.
अच्छा अच्छा।
तो सर, ये
तो
आपके
टोटल
यहाँ पे अभी ऐसे आप भुवनेश्वर में हैं, वो तो वहाँ पे क्या यूनिवर्सिटी से?
भुवनेश्वर में तो है, 4-5 यूनिवर्सिटी है,
ओके ओके.
लेकिन मैं तो
आप कहाँ
फॉरेस्ट,
पे?
मैं फॉरेस्ट एनवायरनमेंट एंड क्लाइमेट चेंज
ओ,
डिपार्टमेंट जो
जी
स्टेट का
जी
है।
जी. ओके सर, ओके ओके. ठीक
ओके,
है, थैंक यू सर.
थैंक यू।
जरूर विजिट करिए कभी जम्मू.
जरूर जरूर कांटेक्ट करेंगे अभी।
जी जी, श्योर सर. ठीक है, थैंक यू सर, थैंक यू.
So now the slide is visible to all of you.
यस सर, इट्स विजिबल.
Okay, okay. So a lot of applications are there. So we will discuss only the coastal zone studies, specifically for different applications are there. So different applications of geoinformatics across various sectors are there. So a lot of sectors are there, more than 10, 15 sectors are there. So some of the sectors are mentioned here. So natural resource management. So nowadays a lot of applications are there in remote sensing and GIS for the application of geoinformatics in natural resource management, like the monitoring of forest areas. So forest classifications are there, water bodies, so change of water bodies and wetland management, then minerals, so the change in the area of the mining areas, then soil types, agricultural land. So all of the natural resource managements are nowadays uh, mm, used for this geoinformatics. And then the urban and regional planning, and in this the change in the urban sprawls and transportation networks, infrastructure planning, smart city development. So all these are works are used for the application of the remote sensing and geoinformatics. Then the disaster management, so early warning systems, damage assessment during floods, cyclone, earthquake. Likewise, the agriculture and precision farming and environmental monitoring like pollution, climate change effects, wetland, biodiversities. Then groundwater, watershed management, coastal zone management, navigation and transportation, public health and epidemiology, and defense and security. So different sectors are there. So nowadays all sectors are covered under the application of the different GIS system. So today we will discuss the uh, coastal applications using remote sensing and GIS. So this is the update from April 2025, that the coastline of the India is now increased from 7,560.6 kilometer to 11,098 kilometers. So it is the official declaration of the Ministry of Shipping in April 2025, and approximately 3,582 kilometer increase of the coastline. And similarly, the Odisha coastline also, previously it is 480 kilometer, now it is 574.7 kilometer. So it is approximately 575 kilometer. So how this is increased? So this is increased due to the include of some islands, some river island, and then coastal islands are there. So their boundaries are included. There is the part of the coastline of the India. So that's why the inclusion of the extra island boundaries, and that's why the overall coastline is increased. So otherwise, there is no general coastline is increased. This is the official declaration by Ministry of Ports, Shipping and Waterways and Transport Research Wings. That is 29th April 2025. So recently it is changed and this is declared. So now there is a trending in coastal regulation zone. So in the coastal areas, there is a regulation zone. So uh, there are four zones are there. So according to these four zones, so which are sensible and which are non-sensible and which are ready to approval for the different construction projects, which are restriction for the construction of different developmental projects based on the zones they are calculated. So now in the 2019 notification according to the CRZ classification, coastal length within the 500 meter, the maximum 500 meter from the coastline, that is high tide line, it is calculated as this CRZ zone. So CRZ1, what is CRZ1? So it is a ecologically sensitive region, that is which includes some mangrove forest, which is a evergreen forest, and coral reefs, which are seen in the Gulf of Gulf of Mannar, then some part of the Gujarat, in some Andaman Nicobar, and in some Maharashtra area. So there is the coral reefs, then biosphere reserve, and so on. So a lot of uh, eco-sensitive zones are there, like sand dunes are also there. Then the reserve forest are also there. So and then horso crab is also there. So these eco-sensitive zones are considered as a CRZ1. So there is no developmental activities are there in the CRZ1. Then CRZ2, that is a urban area near the coastal area, like Mumbai, and in the Puri in Odisha, and Visakhapatnam in the Andhra Pradesh. So these 500 meter from coastline is calculated the CRZ2. Then CRZ3, that is a rural area in the coastal zone. Then CRZ4 is the all the water bodies and all the creek water bodies which a tidal influence is there. That is called CRZ4. So this is the image of CRZ1, CRZ2, CRZ3, and CRZ4. So high tide line is the mark. This is the high tide line. This is the low tide line. So this is the sea. So this area is towards the land part. So this is the red area is the high tide line. So high tide to low tide, that is the intertidal zone, and in this intertidal it is also considered as a CRZ1. So this type of zones are there for regulating the coastal areas. As this is the eco-sensitive zone, that's why lot of regulations are applied to minimize the pollution and other uh, destruction and erosion of the coastline. So then the issue, the 40% of the total world population lives within that 100 kilometer of the coast. There is a rapid increase in the coastal infrastructure due to the presence of all the resources. Then coastal mining, one of the issues. So coastal mining is considered that some of the sand mining and some of the rare earth materials are there, just like zircon and other heavy metals are there, which are used for different aircraft building, then other sensors building. So Some of the rare earth are found in Odisha southern coast, that is near the Gopalpur coast, and some rare earth minerals are found in Kerala. So these are under the Ministry of Atomic Energy. So some of the heavy metals are also found. So this is also important for different developmental activities. Then most of the uh, uh, cyclone and flood, tsunamis are hit to the coastal areas. So this is that's why it is more vulnerable for different calamities and different natural activities. That's why the regulation zone is very much important for restrict different development in the sensitive areas. And then coastal habitats like olive ridley turtles nesting ground is also one of the important habitat in most of the Odisha. Also, it is found in mass nesting near Kendrapada and Maharashtra, some parts, and Kerala in some parts also there. So, a lot of coastal habitats are there for olive ridley, then horso crab, then other features are there, just like sea cow, dudong, that is called as dudong in southern Tamil Nadu, which are near the Rameswaram area. So the coastal issue, some of the issues are there in the coastal areas. The, that is the coastal erosion and coastal degradations are there due to the uh, tidal effect, and mangrove and coral degradations are there. Also, it found in most of the areas. Then natural disasters, then population pressure impact, in construction of port, harbor, and sewage wastewater disposal is one of the issue. Then in industrial effluent, solid waste disposal, coastal mining, constructions, then ingress of seawater, saltwater intrusion. So some of the areas are there where the groundwater is contaminated with salt water, so it is not drinkable due to the saltwater intrusion. Then reduction of coastal sediment supply. Then these are the impact to the tourism in the coastal areas. So how this remote sensing is helpful for the coastal studies. So a lot of passive sensor and active sensor are used for ocean color monitoring, sea surface temperature mapping, salinity mapping, surface roughness, surface slope. So these are helpful for the coastal studies, and lot of sensors are there in remote sensing technology. So each sensor have different applications. Visible sensors have different applications, and infrared, thermal infrared, then microwave, then radar wave, then hyperspectral sensing. So all these sensors are used for different application and monitoring in the coastal areas for the well-being of the uh, society. So this is the JS used for different environments. Then monitoring and modeling. So in the coastal area, some of the coastal zone information system like soil line change mapping. So soil line change mapping means how the coastline changes over the years from 1990 to 2025. So based on the different satellite image of different times, we can calculate how the soul line changes and how much distance is shifted towards sea, or it is eroded towards the land. So shoreline change mapping is one of the important mapping which is used with the help of remote sensing techniques. Then sediment transport information, coastal erosion modeling, so DCS model, INVEST model, these are the models used for the coastal vulnerability studies, shoreline mapping. So you can use this model. It is freely available in USGS site. That is INVEST model, and that is uh, DCS model, distress shoreline analysis model. Then ecological modeling, then vulnerability studies. So a lot of vulnerability studies based on the parameters like grid-based vulnerability studies, then village-level vulnerability studies based on the availability of the parameter like population densities, then soil characteristics, then flood intensity, then forest changes. So all these are included as a parameter for the calculation of the vulnerability of these coastal areas. So these are the some coastal features seen in the LISPOR image. LISPOR is generally the false color satellite image. So in this false color image, the red zones are the vegetative areas. That is, I think some mangroves areas are there. So it is indicated in the red zone, and some salt pans are there. Then reefs are there, fringing reefs are there. Then high tide line. So maximum tidal water line, that is called high tide line, is there. Then low tide, so this is the low tide line. So these are the mud flat areas. So in the intertidal zone, there is a mud flat area. So it is also mapped with the help of this LISPOR satellite image. So in the LISPOR satellite image, mangrove vegetation is clearly visible with a smooth structure. That's why mangrove mapping are used. Mangrove mapping are conducted with the help of some all the false color like LISPOR, then Sentinel data. Then different wetland classifications are there. Then mud flat, tidal flat, then sand, rocks, then vegetated wetland, that is mangroves, marsh vegetation, that is salt marsh. All these are classified according to the different level. Then this is the subtitle mud flats, and these are the mud flats areas. Then this is the intertidal mud flat. So this, the intertidal zone is very wide, and these are the mud flat areas. It looks like some gray level data in the false color image, and this is the field data which is seen in these areas. So in these mud flat areas, generally grows all the uh, mangrove plants and some salt marsh plants. So these are all eco eco-sensitive area as per the CRZ notification 2019. So there is restricted to any developmental activity in the mangrove forest and any salt marsh areas. And mud flat also one of the eco-sensitive zone because it is in the intertidal zone. Then high tide mud flat with salt areas are there. So this is the picture of this area. So this scrub are the salt marsh area, and it is the mud flat area. Then coastal land use and land cover maps. So coastal area is very dynamic in nature. Sometime we can see some sand dunes are there or some sandbar are there. But after some 2 3 months, so there is a uh, non-availability of this sandbar. So due to some cyclonic effect or some flood area effect, so it is very dynamic. So land cover change can be very uh, in a very small time it can be changed. So a lot of satellite data are there for the classification of this system, and the image and the classification, they have the different features, different habitats are there as compared to the land part. So it can be uh, interpreted with the different false color image along with some field level data. Then this is the coastal land use land cover based on the LISPOR satellite image and other satellite image. Some of the picture of the geomorphic features for the identification are the permanent vegetations is there, that is a still, then born and seawall due to the high effect of the tidal ingress of water. The seawall is constructed for reduction of the erosion area. Then dunes, these are the dunes. The heap of sands are called the dunes. Then base of cliff, that is the cliff area. Then this is the mangrove forest and mangrove area. This is the rocky coast. So this is the STL. The high tide line boundary is there. So maximum tidal water is coming into foot of this wall. That's why it is called high tide line is here. Then this is the permanent vegetation. Some temporary vegetations are there, and this is the satellite image. So these are the casuarina plantation. So it looks like the dark patches in the false color satellite image, but the mangrove vegetation is looks like the smooth red color pictures. So we can distinguish all this vegetation with the help of the different tone pattern. Then the embankment. So this is near the Vitarkanika Pentho area, Odisha. So it is highly eroded area and very highly vulnerable area. So these are mangrove forest. This inside the water body. So this is the embankment which can protect to erosion of the land. And nowadays it is constructed with some different concrete structures. And this is also a STL line, high tide line. So it is in Odisha also. So shoreline change activities are there based on the different data. Then there is a shoreline change atlas is also prepared by the ISRO and NRSA for overview of the changes of the different shoreline. So these are all the mud flood areas, then coastal areas, then this is the port area. So how these changes has happened from 2004 to 2014. So this is the port area. Then this is the erosion area. So this is the erosion area. It is demarcated in this area. So how these changes happen in the coast area? This is the list for 2004. So in this area, that is the opening of the mouth and the sandbar. Then it is gradually changes to this portion. So this is the accretion area in the yellow portions, and the red color is the erosion area. So in this pattern, we can estimate the erosion area and accretion area with the help of different satellites image. Then island dynamics are there. So islands are different, gradually changes from different time period. So it is 2004 and it is 2017. How these island shapes changes from this bigger area to these areas. So due to the plantation of huge plantation in the island, so most of the areas are protected and some upper part is eroded due to the loss of some plantation areas. So in the sandy area is highly vulnerable for erosion. That's why a stable plantation uh, to be planning for the protection of the island. So island dynamics is there and how this island is changes from larger area to small areas. So it's very dynamic coastal environment is there. So a lot of studies are going on in different part of the India for coastal studies, and it is given the most important for different dynamics are there, different eco-sensitives areas are there. So this is a mud flood dynamics which is seen in these areas. Then the coral reefs, mangrove community zones. These are the classification of different different mangrove species diversities are there. Avicennia, this is one of the mangrove species. So how this is changes in different zones. These are reflected in the maps. Then creek. What is the creek? Creek is generally like the drainage, but its characteristic is generally drainage are flowing from higher altitude to lower altitude, but creeks are tidal influence water bodies which are moving from lower altitude to higher altitude due to the influence of tidal water. So these are the creeks and these are saline waters are there. So it is look like some small river and some drainage are looks like the drainage, but it is not the river or the drainage. It is a creek. So most of the coastal area we can found the creeks. So in creeks, a lot of fishery activities are going on in all part of the India. Then coastal ocean monitoring. So the color of the ocean is determined by the interaction of light with constituent present in the water. Some different phytoplanktons and inorganic particulate matters are there, and sedomes are there. So due to the presence of phytoplanktons, inorganic particulate matters, then some river sediments are there. So based on this, the color of the ocean is changed. Some areas like seagrass are found. Some area seagrass is found. So these are look like a different pattern. Some area that is coral reefs are found. So these are also looks like some different pattern. And in the thermal bands, if the temperature of the ocean is different, then it also looks like a different pattern. So based on the temperature, then presence of the phytoplankton and inorganic particulate matters, the ocean color is changes in different areas. So phytoplankton generally contain chlorophyll, which absorbs light and at blue and red wavelength and transmit in the green areas. The inorganic particulate matter has light scattering characteristics and substances dissolved in water mainly absorb light in shorter wavelength. So the case one water and case two water. So this is a some look like the blue color due to the single phytoplankton areas. Then due to the dissolved organic matter, suspended sediments, that is look like some green pattern. So due to some dissolved oxygen, sorry, due to some dissolved matters and some organic matters, the water color is different for different areas. Then ocean color remote sensing. So this is the technique how this color is changes, and based on the color we can calculate the presence of different suspended sediments. So different parameters are used for the atmospheric corrections, and biooptimal algorithm are used. Then for the ocean color monitoring. So these are some algorithms are there for calculation of different also ocean color monitoring. Then sea surface, then suspended materials are there. Then this is the different color of the ocean in the Gulf of Kutch. This is also changes in different areas. Then the sediment concentration in different part and different region is different. Then bottom sediment concentration from synoptic ocean color monitoring observations are there in 2004. Then 16 December 2004, 12 December 2004. So different time there is a different suspended sediments, and the color of the ocean is also different. And due to some tidal variabilities and wind distortions, color of the ocean also changes. So this is the temporal dynamics in the surface of the ocean. So these are the features of the ocean color. Then formation of eddies at the ocean areas. So generally eddies are a circular movement of water, wind and dust. So when the circular movement occur in the ocean areas, then the color of the uh, ocean surface are detected by the satellite sensors. Then it looks like a different pattern. Then we can calculate. Then this is the eddies. Eddies means there is the circular movement of water due to some wind and tidal influence. So most of the areas perform the some eddies are there. So these are the graphs, and these are the development of the plume dynamics. Then the bathymetry. What is bathymetry? Bathymetry is the depth. It's a measurement of the depth of the ocean. So bathymetry studies means the study of depth of the ocean. So generally we can calculate the height of the land part in meter or in centimeter, but in the ocean areas we can calculate the depth of the ocean with the use of bathymetry. So the standard in the calculation is the one in not in meter, it is in the fathom. One fathom is 6 feet, so it is calculated in fathom. So these are some hydrodynamic simulations are there, and this is a concentration of different domains. So this is a numerical simulation of suspended sediment transport. So for different winter season, spring season, there is a change in the ocean sediments. Then what is the use of SAR? SAR is the full form is synthetic aperture radar. So it is an active sensor. So most of the applications are used in the ocean areas and coastal areas. So it can penetrate through the cloud. That's why it is used for all time, all weather time phenomena. So SAR is very much useful in the uh, monsoon season, also in flood time and cyclonic time. So this is a active sensor. So this is a SAR image. It looks like the black and white image. So it is generally operation in the backscatter technology. So it has own emitter. When it can emit, then it is scattered, then it is received with this sensor. So this information is useful for different application. So hydrodynamics modules, ocean backscatter are used, modulation, velocity bouncing. Then SAR image parameters are there, dispersion relations, linear MTF, non-linear MTF. They are not useful now. This is a SAR image. So it is not a satellite in, from the optical sensor image. It is a SAR scatter, backscatter based image. So oil spill and some coastal floodings are very much mapping are useful for this SAR image. The ocean wave parameter are also calculated with the help of this SAR image. So the ripples are also detected in these areas. So it is directed in this direction, the eastern directions. So based on the satellite image, we can calculate the direction of the wind and with the help of this SAR image. Then SAR altimeter. So in this altimeter, we can calculate the height information, wave height informations. So which area has a highest wave height and which area is low wave height. Based on this, there is some developmental works are going on. So ship movement are also monitoring with the help of this wave height monitoring information. So this is a list for satellite image. This is a list for satellite image. These are the ripples are there. So based on the satellite image, we can also calculate the wave area and calm area. So in this wave area, we can see this is a formation is there. These are the ripples. But in these areas, this is a smooth structure is there. So we can estimate that it is a calm area and it is a wave area. So like this, all the information are submitted to IMD and other websites for public information. Then coastal currents also detected with the help of satellite image, that is SAR image. So the East Australian current. So it is the current which is look like this brighter tone as compared to the surrounding areas. So this is the current uh, moving from north-south direction. So it is also estimated with the help of SAR image, that is synthetic aperture radar. And this is the height of the tidal um, characteristics. And this is the map of red color is a high altitude tidal informations, and this blue color is a low altitude tidal information. So these are the some ocean current movements are also calculated with the help of different satellite images. Then coastal bathymetry is also calculated based on the satellite image. Then these are the bathymetry derived linear dispersion relation. So these are the bathymetry information data detected in different color. So from below, that is blue to red. So blue is low elevation, low depth areas. Then red is a high depth areas. So it is look like this in the map. So this is the coastal bathymetry structure. This is also one of the satellite image. We can calculate the bathymetry data. So lot of bathymetry models are there. So we can use with the help of SAR image. And nowadays, some in the website, some bathymetry informations are also shared in different formats, and in also image formats are there for coastal oceans studies. Then coastal bathymetry also detected with the help of the LIDAR data, that is light detecting and ranging data. So this is the technique, backscatter technique. Then this is the image created with the help of the LIDAR technology. Then all these coastal thermal fonts or upwell zones, all these zones are calculated with the help of thermal energy. And this is the thermal image, that is based on the temperature, surface temperature of the satellite image. We can calculate the which area is uh, more temperature as compared to the low temperature areas. So generally thermal image is useful for monitoring the coastal environment and ocean environments, and cyclone monitoring, and some fishing activities. So generally thermal high temperature areas are there where more fishing activities are there. So some zones are there in which some fishing activities is more as per the different temperature zones are there. So this is the thermal plume. So high temperature area in a short, very um, small areas are also detected. So this is the thermal maps based on the different satellite images. Then multispectral and hyperspectral remote sensing, which are used for the coastal studies. In the multispectral, maximum 10 to 15 spectral bands are used in different wavelength. But in hyperspectral remote sensing, more than 200 spectral bands are there and very low bandwidths are there. So within this low bandwidth, more information are collected, and the minute information are detected. So in the multispectral, we can calculate identify the features based on the visual interpretations. But in the hyperspectral image, we can detect different specific characteristic and specific features based on the graph. So this graph shows this is a one type of metal, or this is a one type of structure, and this is a one type of soil structure, or this is a one type of uh, plant. So based on the graph, we can estimate it is a different. So all these features give different graph patterns based on their reflectance value and sensor detections. So a lot of bio-optical models are there, and for hyperspectral remote sensing. And so nowadays, the ecological mapping of silica lake, that is Ramsar site, then classification of beach in Mangalore, and coastal classification, all these hyperspectral images are used. This is a silica lake. So this is a map which is prepared based on the hyperspectral sensors. So this is the aquatic vegetation informations are there in the Chilika Lake. So generally Chilika lakes have the seagrass activities are there. So I think these are the some seagrass activities are there in the blue color, and other activities are also there. So seagrass mapping is also very much useful for uh, different coastal areas with the help of hyperspectral remote sensing. So these are also detected that there is the mud, sand, and algae areas based on the hyperspectral image. So there's a sand abundance, then the mud flat height, then water column. So all these are calculated. Then this is the mud flat areas with the help of the hyperspectral satellite image. Hyperspectral satellite image are very costly satellite image. Then sediment size estimation from Everest. Everest is one of the hyperspectral satellite image, which is a very high resolution. So these are some sediment size estimation from Everest. These are some different bands of the satellite image, and these are different features of the coastal areas. And this is the photograph of the this is the mangrove area in the edge photograph. Then this is the fishbone channel. Then this is the degraded mangrove area, and this is the creek. This is the creek area. Then a lot of geomorphological features are there, like mud flat, then sand dunes. These are the geomorphological features. So geomorphic morphological features in the coastal area is different, and for the land area it is also different. So these are all mapped with the help of the different remote sensing sensor. So these are the mud-flat areas calculated with the help of this different satellite images. Then interferometry for coastal subsidence. So interferometry is generally used for the different displacement rate and calculations. So some subsidence or some changes in the position of some part of the land. So this is used for very precise location information. It is with the help of the SAR technology, that is synthetic aperture radar. Then sea level rise is one of the biggest issue nowadays. So sea level rise also calculated in with the help of different remote sensing information. Then the coastal vulnerability index mapping, that is CVI. So these are the formulas. A lot of formulas are there based on the different formulas. Vulnerability studies are there. So this is based on the vulnerability studies. The categories are created in the coastal areas. So the red areas is the highly vulnerable areas. Then blue color areas, that is the low vulnerable areas. So nowadays, coastal vulnerability index mapping is very trend due to the new technological advancement and availability of the different open source data and use of remote sensing and different models are also nowadays uh, coming out. Like invest model is there, then DCS model is there. A lot of models are there. Then machine learning technology also there for vulnerability studies of the coastal areas using different softwares and also Google Earth Engine and with the help of Python coding. So these are the vulnerability lines. So is the highly vulnerable area. So mudflood area is generally highly vulnerable areas. So vulnerable area generally the low lying areas are more vulnerable as compared to the height heighted areas. So it is easily detected with the help of the different satellite images based on the information of the height information and geomorphological features presence in these areas, eco-sensitive zones presence of the areas, then high population densities near the low-lying areas also creates a problem for different uh, climatic factors. So thank you. Some these are the some applications of the coastal studies and coastal applications, and different sensors, different satellite images are used for different applications, from coastal vulnerability to ocean color monitoring, sea shoreline change, then geomorphological studies, ecological sensitive area studies, then coastal zone management plan, preparation of the coastal zone management plan, then fishing activities. All these applications are, all these different sectors are used with the help of all these remote sensing technology and different nowadays different new sensors are also there for preparing the different applications. So these are the some coastal applications with the help of remote sensing technology. Then we'll see all other applications in next classes like disaster management and urban planning, agriculture sector, health sector. So different sector have different application, different satellite images are used, different techniques are used. So which techniques are used for different sector we can discuss in the next class. Then thank you, and if any doubts you can ask me. Okay, any doubts are there? Hello. Anmol.
Yes, sir.
So any doubt or we can
No, sir. No.
stop this? Okay, then we'll
Okay,
see
sir.
the
Okay.
next application in next class. Okay.
Okay, sir.
Okay. Thank you.
Thank you.
Good night.
Good night.